Let's evaluate this two-sided limit. Limit as x approaches 2 of x squared minus 2x minus 8 over x squared minus 5x plus 6. So I would say whenever possible, factor first. So I'm going to factor this thing, x minus 4 times x plus 2, and then this thing factors as x minus 3 times x minus 2. So in order to compute the limit, I need to check two one-sided limits. So when I look at x approaches 2 from the left, I want to look at numbers that are close to 2 and less than 2. So let's try x equals 1.9. So, oh, by the way, is this thing even infinite? If I plug a 2 in everywhere I see an x, this is certainly going to give me the form, let's see, negative 2 times 4. So this is going to give me negative 8. And then when I plug a 2 in here, I'm going to get 0. So this has the form that we want. The numerator is non-zero, the denominator is 0. So that suggests that the final answer is either plus or minus infinity or does not exist. So for the one-sided limit, when I look at 2 from the left, I'm going to check 1.9. So everywhere I see an x, I'm going to write 1.9. And all I care about is the sign. Right? I don't need to crunch any numbers. So for example, when I plug in 1.9 here, I'm going to get a negative. When I plug in a 1.9 here, I'm going to get a positive. When I plug in a 1.9 here, I get a negative. And then when I plug in a 1.9 here, I get a negative. And so that tells me in the numerator, I've got a negative. In the denominator, I've got a positive. So this tells me that the limit as x approaches 2 from the left right, the limit as x approaches 2 from the left is going to be negative infinity, negative infinity. So now I want to look at the limit as x approaches 2 from the right. So as x approaches 2 from the right, now I want to look at numbers close to 2 to the right of 2. So let's try 2.1. When I plug in 2.1, everywhere I see an x, what kind of sign am I going to get? Well, here I'm going to get a negative. Here I'm going to get a positive. In the third term, I'm going to get a negative. And then 2.1 here is going to give me a positive. So I've got negative, positive, so that's a negative. And then here I've got a negative, positive, that's a negative. And so negative over a negative, that is a positive. So I know that the limit as x approaches 2 from the right, now that is going to be positive infinity. So one of the one-sided limits is positive infinity. The other one-sided limit is negative infinity. So because these two things do not match, the limit, the two-sided limit, does not exist. So the limit as x approaches 2, that does not exist. So this would be, right, this would be a good final answer for this particular exercise. Right? The limit as x approaches 2 does not exist because the two one-sided limits are not equal. Here's an example involving trigonometry. We want to look at, and this is just a one-sided limit, so I want to look at the limit as x approaches 2 pi from the left of the function x times cosecant of x. So before we get started, I think it would be a good idea to rewrite this thing using more familiar trig functions like sine or cosine. So remember, cosecant is the same thing as 1 over sine. So this is really now the limit as x approaches 2 pi from the left of x over sine of x. And certainly here, if I plug in a 2 pi, I'm going to get something of the form 2 pi over 0. So that suggests that our answer here is going to be plus or minus infinity. Again, we just need to figure out which one. So usually we would take some number that's close to 2 pi but to the left. Here I'm just going to use a graph of sine of x. So I've got x in the numerator, sine of x in the denominator. So the question is, what happens to the sine function as we move towards 2 pi from the left? So what kind of sign do I get here? So as I move towards 2 pi from the left, right, so here's 2 pi, and I want to go there from the left. How do I approach 0 as x approaches 2 pi from the left? Well, the function approaches 0 from below. In other words, all of these values of y are negative. Sine of x returns negative numbers when I am close to 2 pi and to the left of 2 pi. So really, what is this thing then? Well, as x approaches 2 pi, that's certainly positive in the numerator. And then what about in the denominator? Well, according to the graph, as x gets close to 2 pi, these numbers are negative. So here I get a negative. And so the answer to this then is just positive over a negative, so that should just be a negative infinity. So that's a good final answer for this thing. So here we used a little bit of graphical, a little bit of numerical to figure out this infinite limit. Here we want to find the one-sided limit as x approaches 4 from the left of natural log of 16 minus x squared. So this one's not a fraction, so we can't really apply the technique from the last couple of examples. But let's just look at what the natural log function looks like. So the natural log of anything, natural log of x, natural log of u, natural log of smiley face. As the thing in the parentheses gets closer and closer to 0 from the right, so as the smiley face gets close to 0 from the right, the natural log function will approach negative infinity, right? So natural log of the thing will approach negative infinity. So the natural log function has this vertical asymptote built in, so we want to exploit that fact for this particular problem. So how can I use this to address this problem? Well, if x approaches 4 from the left, that tells me that x is certainly less than 4. So now I want to take this expression x less than 4 and build it up to 16 minus x squared. If x is less than 4, what's going to cause this thing to do? So if x is less than 4, that means that x squared is less than 16. And that means that 16 minus x squared is bigger than 0. So that tells me that the thing in the parentheses will approach 0 from the right. So 16 minus x squared will approach 0 from the right. That means the thing in the parentheses, the smiley face if you like, approaches 0 from the right. Therefore, natural log of that thing must approach negative infinity. So the answer to this thing is negative infinity. What if we would approach 0 from, or sorry, what if we approach 4 from the right? So in that case, if we approach 4 from the right, that would cause us to, that would cause 16 minus x squared to approach 0 from the left. And we know the natural log of a thing to the left of 0 does not exist. So if I change this minus to a plus, the answer here would change to does not exist. It'd be a good idea to write down those details and see that you get the same answer.